We can reverse the age of an old mouse's brain, so they have dementia. We spend 3 weeks reversing the age of the brain. We just give them an intravenous injection of our therapy, turn it on for 4 weeks, and those mice have a young brain, and they have their ability to learn again. So I imagine a day where we will have an infusion either in our eye or in our whole body, and we just take a drug to turn those genes on. We use doxycycline, just your antibiotic.
As a trigger for those genes.
It's the trigger. We don't need an antibiotic. It's not used as an antibiotic. It's an on-off switch. But we can reset the body. And so after the eye, we're going to go after hearing and dementia.
Yes.
And there will be a day, I believe, where you will be able to rejuvenate your brain and get back memories, get your ability to learn again.
Wow. Let's give it up for that. I mean, are you guys hearing the same thing? I just want to jump up and down here. Listen, I've asked Ray Kurzweil, I've asked George Church, and now I'm asking you this idea of a longevity escape velocity target date. Let me give you a couple of decades and tell me, as a betting man, under or over, within the next decade, in the second decade, in the third decade?
Do you mean escape velocity or the singularity?
So when we will have the ability to go and get a mechanism that will allow us to basically age in place or age in reverse, so that we're no longer, if every year we're alive, we're extending our lifespan for more than a year.
Well, it's already here. It's just not available widely.
It's already here, ladies and gentlemen. At least if you're a mouse.
Well, so I'm not talking about our therapy. That's hardcore. That's a rocket versus the Wright brothers. But there are technologies now and some published papers that.
Are you talking about like rapamycin?
Rapamycin and combinations. So Greg Fahey has done good work, continues to do good work on combinations of molecules that have age reversal properties. So I believe that there are already molecules and drugs that you can use to reset your age somewhat, not go back to being 30 years old again if you're my age. Our ability in my lab, and presumably scientists across the world if they're smart, to use AI to answer questions that we were not able to. I wake up and poor Serena, my partner who's here with me, knows that I read papers first thing in the morning, usually. And so that is a real tax on my brain, but I can only cover 100 papers a morning.
7,000 papers published in the medical science every day.
Yeah, so that alone, the ability to synthesize that every day would be great, and we're doing that now. But just ability to ask AI how to find the best molecules that can mimic the OSK gene therapy, you can ask AI that. You can get decent answers. So we are going to have exponential increases in the pace of this field. So it's not just AI helping us be superhuman. It's also the funding level, the amount of money that has gone into certain companies in this area. Since we published that paper in Nature, there's been investment in the billions of dollars.
Milner and Jeff Bezos, the Evolution. I was showing him some of the companies earlier that are capitalized.
And the reason is, perhaps to state the obvious, is that this is an area that's no longer the backwater of biology. It's pharmaceutical development, and those that capture that land will be the dominant industry of this century.
Amazing. One of the points I remember in discussion with you and George Church was that it's likely that a real rejuvenation therapeutic will, if it works for one tissue and organ, will work for the entire body.
That's also lucky, but it's true. That's what we find in animals. Now, I haven't injected myself yet. I'm probably not going to do that for a few years. But in mice, I'm shocked that what works in the eye, in the optic nerves, the nerve cells, works in the epithelial cells in the retina, works in the outer layer of cells on the retina, works in the kidney we just published, the muscle. If it works in all those different cell types,